Hi everyone, I am Lakshmi Geetika Gandham, a BTech student from SRK Engineering College, specializing in cybersecurity and IoT. As part of my internship at Emertxe, I worked on simulating an automatic washing machine using embedded C program and MPLAB IDE. In this demo, I will explain the concepts I learned, the coding part, the analysis behind each function, and how the system works step by step like washing machine. Now, coming to the table of contents, introduction, embedded C, embedded system and types, project objectives, tools used, functional requirements, implementation, and conclusion. And coming to the introduction part, washing machines are essential appliances that automate the process of cleaning clothes efficiently. In today's fast paced world, they help save time, water, and physical effort, becoming a must have in every home. With advancements in technology, users now expect smart, fully automatic systems for a better laundry experience. The project focused on designing a mini prototype of an automatic washing machine using the Picsim F877A microcontroller simulating operations. Now, coming to the embedded C program, C language is widely used in system software and embedded applications because it is fast and efficient. It gives the direct control over hardware like memory, timers, and input and output ports. C is used to create operating systems, devices, firmware for electronic devices. Embedded C helps in programming microcontrollers in systems like washing machines and automation tools. It supports step-by-step structured coding, which makes it easier to develop and fix errors in embedded programs. C is portable and lightweight, which makes it suitable for various hardware platforms. Now coming to the embedded C program, for the data types we are used characters, float, int, double, and the jump statements, go to statement, break statement, continue statement, and for the loops, for loop and while loop, and the decision, if else, and arrays, modifiers, signed, unsigned, short, long, and the pointers, user defined data types, enums, and type definitions. And coming to the embedded systems, so what is embedded systems? An embedded systems is an electronic system that has software and embedded in computer hardware. It is programmable or non-programmable. Depends on the task specification. To be concerned about the characteristics of an embedded system involve its speed, size, power, accuracy, and adaptability. Therefore, when the embedded system performs the operations at high speed, it can be used for real-time applications. To be concerned about the characteristics of an embedded systems, we can classify it into two broad categories are as follows. The first one is based on performance and functional requirements, and the second one is based on performance of the microcontroller. Now, coming to the types of embedded systems are two types we already know based on performance and the functional requirements and based on performance of microcontroller. Now coming to the based on performance and functional requirements, standalone embedded system, real-time embedded system, network and mobile embedded systems. And coming to the based on performance of the microcontroller, small scale embedded systems, medium scale embedded systems, sophisticated embedded systems. And the first one, standalone embedded system. The system don't require host system like a computer system. It works by itself. It takes the input from the input ports, either analog or digital, and processes computers and transfers the data and gives the resulting data through the connected device which controls, drives, or displays the associated devices. For example, standalone embedded systems are MP3 players, digital cameras, video game consoles, microwave ovens, and temperature measurement systems. And the next one is real-time embedded systems. A system called real-time embedded system which gives a required output in a particular time. These types of embedded systems follow the time deadlines for completion of a task. Real-time embedded systems are classified into three types such as soft real-time embedded systems and hard real-time embedded systems based on the precisions. And the next one is network embedded systems. Network embedded systems are related to networks to access the resources. The connected network can be LAN, WAN, or the internet. The connection can be any wired or wireless. This kind of embedded systems is fastest growing technological area in embedded system applications. This embedded web server is a type of system wherein all embedded devices are connected to a web server and accessed and controlled by a web browser. For example, the LAN network embedded system is a home security system wherein all sensors are connected and run on the protected protocol TCP or IP. Now coming to the types of embedded systems. Mobile embedded system. Mobile embedded systems are highly preferable in portable embedded devices like cell phones, mobiles, digital cameras, wireless MP3 players, and personal digital assistants, etc. The basic limitation of these devices is the other resources and limitation of memory. Another category of embedded systems based on performance of microcontroller, and it is further classified into three categories as follows: small scale embedded system, medium scale embedded system, sophisticated embedded system. And now coming to the project objectives. This project focus on simulating a washing machine using Picsim lab, aiming to replicate real-world washing machine functionality in a virtual environment, using various features in the keypad to perform operations on the washing machine, using CLCD for displaying options and the time left complete the process, using timers for tracking the time left complete the selected process, using a motor to represent the ongoing process, and using the buzzer to indicate door status and program completion. And these are the tools we are used in our project: MPLab XIDE and XC8 compiler Picsim lab. And the MPLab XCDE is a software tool used to write, compile, and debug programs for PIC microcontrollers. It is developed by Microchip and supports embedded C program. In the washing machine project, MPLab XIDE is used to write and test the control logic like mode selection, timer, and buzzer alerts for PIC16 F877A microcontroller. X8 compiler is a C compiler provided by Microchip used to convert embedded C code into machine code for 8-bit PIC microcontrollers. In the washing machine project, X8 compiler is used to compile the control program written in embedded C so it can run on the PIC16 F877A microcontroller. And the next one is Picsim Lab. Picsim Lab is a virtual simulator used to test PIC microcontroller based projects without real hardware. It helps visualize circuit behavior with components like LCDs, switches, and buzzers. In the washing machine project, Picsim Lab is used to simulate the working of the PIC16 F877A microcontroller, LCD displays, and keypad buttons to test the washing process visually. And the functional requirements for the microcontroller, the functional requirements are power on for switch 5, pass or stop for switch 6, navigation for switch 4, door status for switch 1, and the display washing status, CLCD, buzzer, and motor. And coming to the PIC board, the PIC board is a development board designed for programming and texting PIC microcontrollers, especially the PIC16 F877A. It provides built-in components like crystal, oscillator, reset button, power supply input, and Headers for connecting external modules like LCD, switches, and buzzers. This board is very useful for embedded system projects and helps beginners understand microcontroller programming. In washing machine project, the Pix Genius board is used to connect and control all components like the keypad, LCDs, and buzzer, making it easy to test the washing logic in real time. And now coming to the timers in PIC16 F877A. The PIC16 F877A is an 8-bit microcontroller from Microchip that includes three built-in timers. Timer 0, Timer 1 and Timer 2. These timers are essential for generating accurate delays, continuing external events, and creating time-based functions without blocking the main program flow. Each timer operates in different modes 8-bit or 16-bit and can be configured for a variety of timing applications. Timers in the PIC16 F877A are widely used in embedded projects for tasks like flash generation, event counting, interrupt triggering, and creating precise time delays. The microcontroller also supports interrupt on overflow, allowing the main code to respond immediately when a timer reaches its limits. Now coming to the CLCD in PIC16 F877A, it is a commonly used in display module in embedded systems that can show 16 characters per lines on two lines. It operates in 4-bit or 8-bit mode and is used to display text, numbers, and messages directly from a microcontroller. In the PIC16 F877A based washing machine project, the CLCD is used to show important information like power status, mode selection, timer countdown, and user instructions. It connects to the microcontroller through data and control pins, making it easy to integrate and program using embedded C. And the next one is digital keypad in PIC16 F877A. A digital keypad is a set of push buttons arranged in a matrix format commonly used an input device in embedded systems. It allows user to give commands like start or stop or mode selection by pressing buttons that send signals to the microcontroller. In the PIC16 F877A based washing machine project, the digital keypad is used to take the user input for actions such as starting the wash cycle, selecting the washing mode, or stopping the machine. Each key is connected to an input pin and the controller continuously scans the keypad to detect which button is passed. And the next output images. When we start the power on button, it will display like this. Press key 5 to power on washing machine. Now, when we press the switch 5 button, it will display like this. Washing program display heavy dedicates. So, now when we press the selection, when we select any mode in this, so next it will display like this. Press switch 5 for start and switch 6 for stop. And when we press the switch 5, it will timer run and the program will start. After completion all the program, it display like this: program completed, remove cloths. Now I will show you the full code inside MP Lab and explain how these functions work. Let's open the file and go one by one. And these are all the header files and these are all the source files. Now coming to the first one, clcd.h. The purpose for this defines macros and functions to control the character. And the second one is digital keypad.h. The purpose is handles all keypad input operations using port B. And the next one is main.h. The purpose is global definitions for modes, flags, and peripherals. And the next one is timers.h. The purpose is declares timer functions used for time tracking. And the next one is washing machine header.h. The purpose is declares washing machine display and logic functions. And the next one is clcd.c. The purpose for this controls the LCD display. And the next one is digital keypad.c. The purpose is keypad input logic. And the next one is ISR.c. The purpose for the ISR.c is interrupt service routine for timer 2. And the next one is main.c. The purpose for this main execution loop. And the next one is timers.c. The purpose for this initialize timers. And the next one is washing machine functional def.c. The purpose for this all logic for washing operation state management. Now I will show you the process and output in Picsim lab. So here it is the motor and it is the buzzer. These are pins. These are the switches. RB0 indicates switch 1, RB1 indicates switch 2, RB2 indicates switch 3, RB3 indicates switch 4, RB4 indicates switch 5 and RB5 indicates switch 6. And this is the reset button. When we press switch 5, CLCD displays powering on washing machine and here we select washing program dot here. I used 12 modes in washing program. When press switch 4 short press moves to the next mode. For long press it moves to water level and we select low or high by short press. Next long press it displays switch 5 for start and switch 6 for stop. When we press switch 6, it starts from beginning. So the same process will repeat again because we selected switch 6. Now we selected modes and water level. So now press switch 5 to start. It displays timer run when we'll wait until the timer ends. When switch 1 is pressed, it indicates that washing machine door is open. It responds, the buzzer sounds on and a message is displayed on the LCD. Please close that door. Now, switch 6 is used to pass the washing process. When pressed, the timer stops and the motor operation halts immediately. This ensures the machine stays in safe passed state. Switch 5 is used to resume the process. Once pressed, the timer continues from where it was passed and the motor starts running again. The resuming the washing cycle smoothly. Once the timer reaches 0, the washing process is complete. At that moment, the buzzer sounds to alert the user and the LCD displays the message program completed. Let's wait and see. Okay, here the LCD displays the message Program completed. Please remove clothes. Now we will go to the conclusion part. Coming to the conclusion part, during my internship at Emertxe Information Technology, I gained valuable hands-on experience in embedded systems. I learned to work with microcontrollers, LCDs, keypads, and timers. The washing machine project helped me improve my coding, debugging, and actual problem solving skills. Overall, Emertxe provides a strong foundation in practical knowledge that will benefit my future career. And thank you so much, Emertxe. And it was a good platform to learn. And especially thanks to Priya ma'am.